Hello everybody and welcome back to part 2 of the chapter 7 expressions and assignment statements video. This is for the programming language concepts course. And so we're not going to start at the beginning. I'm going to go and pick up where I left off, and I left off on the concept of short-circuit evaluation. So let's start the slide set here. And so this video will finish up and give you the rest of chapter 7. So for short-circuit evaluation, we learned about this term in assignment number 2 for the Python exploration activity. And to short-circuit is to cut short. It's to end it early. And what are we ending early? The evaluation of expressions. So a short-circuit evaluation of an expression is one in which the result is determined without evaluating all of the operands and or the operators in the expression. As soon as we find something that is true, we end. And then when we end it, the rest of it is just left. And so you can actually come up with some logic where you only have, let's say, one, let's say you come up with like 15 different checks. If this, if this, if this, if this, if this, all over again, like 15 times or so. And the second one actually is true. The second one is going to execute, and then we're done. Like the next one's not going to work, or the next one's not going to work. So it basically cuts short is what that means. So here we have an index that's equal to 1, while the index is less than or equal to the length. And the list, if we put in the index, doesn't equal a value, then do the index to have that one equal to the index plus 1. This is not the C language, by the way. This is Pascal, actually. But it's an example of short-circuit evaluation where if that index value isn't less than or equal to the length, then it's not going to run at all, especially depending upon what the length of the list is. So anyway, that's kind of an example there. In C, C++, and Java, you use the short-circuit evaluation for the usual Boolean operators. So short-circuit evaluation is there all the time. It's just part of the language itself, and it's there in Python as well. The double ands and the double ors can be used with the Boolean operators, but also provides bitwise Boolean operators that are not short-circuited. So you can use the single ampersand or the single or for not short-circuited. You can turn the short-circuiting off if you'd like. So if it's not true or you don't want it to end, you want to continue with the evaluation, then you use the single, which is the not short circuit. Otherwise, you're going to be short-circuiting it if you use the double ands, the ampersands, or the ors operators. Okay, so assignment expressions. So hopefully, from doing the Python exercise, and you should have done that assignment already, by the way, you should hopefully be ready to go with the short-circuit evaluation concept. So assignment expressions. So the general syntax of the simple assignment expression looks like a target value, and then there's an assignment operator, which is generally the equals or the colon equals, depending upon what language you're looking at. And then there's the expression. The typical symbols, and this is where we get to see the C++ and the Java actually came from, Fortran, which is the single equal. Pascal does the colon equals. Algol does it. Modular Ada does the colon equals. And then the equals can be bad if it's overloaded for the relational operation of equality. People do that in C actually because they don't like the double equals. The double equals is the comparison operator in the C language. But some people like to overload the equals so it does the comparison instead. So you can say, instead of 5, if I is equal to 5 and you just put a single equals but you overloaded the operator, then it's doing, is it doing an assignment expression or is it doing a comparison? And then you can overload you can actually change C so it works like Pascal. You can overload the single equals, turn it into a colon equals. And so the colon equals is the equals and the single equals is the comparison operator. And so that makes your code even harder to write. You're like, which language? And you come back here and you say, is this C now? I mean, we could write C code like that now if we wanted to. So yeah, overloading operators from the previous video, not such a good idea when it comes to keeping things consistent for multiple programmers working on the same set of code. If it's only one programmer and you're never going to show your code to anyone, which is highly unlikely, and no one else is ever going to see your code, then you can do whatever you want with it. But if you're going to share your code, you might want to keep it consistent with the C kind of operators here. So anyway, yeah, you can overload the equals and turn it into equality. So here's some more complicated assignment expressions. We can assign multiple targets. For example, and this works, we can go A comma B is equal to 10. Or in conditional targets that work in C, C++, and Java, first is equal to true, then we have a question mark, total, colon, subtotal is equal to 0. Or those are conditions, if it's true. Compound, we can also do compound assignment expressions, C, C++, and Java. The sum is plus equals next or minus equals next. Unary assignment operators, well, we've got the A++ or the plus A. So that is also a unary approach. So when two unary operators apply to the same operand, the association is right to left. So A++ is the same as A++. It's right to left instead of left to right, which is actually kind of funny because right to left would increment the A. So A++ is A+. So it's from the right, the plus plus is added to the A. So if I want to evaluate A, and then I'm going to add the plus plus next to it, then I get, for example, if I go A++ and I see out that to the screen and A was 5, I'm going to get the number 5 printed to the screen. If I go plus plus A and see out the plus plus A, I'm going to get the number 6 printed to the screen. Do we want the plus plus to happen before the evaluation, or do we want the plus plus to happen after the evaluation is what that means? So some people actually think it means the same thing, the plus plus A and the A++, but it doesn't. Actually, there's two separate meanings. Are we going to increment it before we evaluate it, or are we going to increment it after we evaluate it? And if we increment it after we evaluate it, we're actually going right to left instead of left to right, because we evaluate A first, and then from right, we're going to go the plus plus. So we go right to left. So, but you don't really need to know that. Assignment as an expression. C, C++, and Java, the assignment statement itself produces a result, and that's what I was trying to tell you back in the previous video when we were talking about relational expressions. So you can use them as operands in an expression. For example, here, character is equal to get character if it doesn't equal end of file. So this comes back true. So while true, it would just be like saying while true here. So this expression here would not only work, it would get the characters from the file, and then if there was a character, the loop would continue true, 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 true. So you're combining two things together. You're doing the assignment expression, you're producing a result, and you're also checking on the Boolean status of it and using it in a while loop. So you're compounding it all together. It makes it very efficient in only one line of code. The disadvantage to this is another kind of expression side effect often leads to expressions that are hard to read and understand. Yeah, hard to read and understand. Like this one down here, we're going to put it all together. We're going to do a C is equal to D, and we got, well, let's see, I'm not going to read the whole thing, but we have it all compounded together here. Well, that's pretty hard to read. We have a little explanation down here about how to read this thing, but the more you stick all together in one line, the harder it is to actually write it. In the beginning, back in the days of when C programmers, were kind of really exploiting the power of the language, they were writing expressions that were, all put together, that were just compounded, and how many few lines of code can I write to make this work, kind of thing. And in doing so, a lot of the code was sort of it's hard to read. So if you can read old C programmer, original C programmer code, if you can read that, you're in good shape. So mixed mode assignment expressions. In Fortran C and C++, a numeric value can be assigned to any numeric scalar variable. So whenever the conversion is necessary, it's done implicitly. So that's what I mean when you say, float, and you float f, and f is equal to 12. You can actually explicitly do it with the character f. You can go 12f semicolon, and that'll convert the 12 to a float. Or you can leave the f out and just go 12, and then that's going to be converted to a 12.0. In Pascal, and this is a mixed mode assignment expression, this is when we assign the value. Not when we compare it, but when we assign it. So if I have a float, I'm going to put a float in there, whether I give it an int or a float. In Pascal, the integers are assigned to reals, but reals cannot be assigned to integers. Programmer must specify whether the conversion of the real number to an integer is truncated or for whether it's rounded. In Java, only widening works, and it's done when its coercions are done. One of the effective ways to increase the reliability of Java relative to C or C++. Yeah. Java only allows widening conversions. C allows narrowing. So I could go integer I is equal to 12.9.5, 12.9545, whatever, but like put a float value in there, and it would narrow it and make it whatever it was before the decimal. So C will do that, but it's not as reliable because you're truncating the number and you're not actually making it assigned to the correct number. Java doesn't allow that. So yeah, when they created Java, they copied a lot of the not the C++, but the C syntax. They copied a lot of that syntax, but then they also made some logical corrections so that the program language itself was a little bit more reliable. But that's one of the little things they did. They just they stopped the narrowing conversions that are a bit unsafe. In Java and Ada and Modular 2, there's no assignment coercion. You have to put an exact number in there. And then some people say that's why Ada is known to be more of a reliable language, because Ada doesn't do any implicit conversions. You actually have to put a real number in there that works. You can't just put any number you want and have it coerced in there. It won't do it. In all languages that allow mixed mode assignments, the coercion takes place only after the right side expression has been evaluated. Yes, you need to evaluate the number first, and then you can do the coercion second. So in a right to left kind of assignment. So that was the end of chapter number 7. It only had a couple slides left on it. I'm going to stop. I'm not going to do chapter 8 here. I'm going to stop. But instead, I'm going to kind of go through, and what I want to do is talk about, I know this is chapter 7, but I also want to talk about the assignment that's due coming up. And so we have in the 311 course, we have some assignments. And number 5 was the object-oriented assignment. And if you remember the object-oriented assignment, you were to watch the video on that one for the secret alternative assignment, so you don't have to do the one that's in there. Number 6. Number 6 says you're going to read chapter 5, which is on names, bindings, type checking, and scopes. And you're going to answer some questions. And the questions that you're going to answer, there's 5 of them in here. And I wanted to make a couple of notes here. And what I'm going to do is dedicate a special video to this, and it will be the next video, where I'm going to talk about, I'm not going to answer all these questions for you, but I'm going to discuss this in a lot more detail, so you have a few hints in terms of how to approach this. But just in case you're starting to work on it this week, because this is going to happen next week, but just in case you start working on it this week, what I want you to keep in mind is that there's nothing in here about the page length. There's nothing in here about, well, hopefully there's something in here about plagiarism, but there isn't. So I don't want you to plagiarize this, obviously. And I don't want you to write a dissertation here either. So for example, some programming languages are typeless. And what I want to do is kind of address the first question for you here. What are some obvious advantages and disadvantages of having no types in a language? Okay. Answer in your own words. I cannot stress this enough. Answer in your own words. Okay, so what does that mean? some languages are typeless. Okay, so they don't have data types. And what you want to do is make sure you actually read chapter 5 before you attempt to answer these questions. Okay, so if the languages are typeless, what are some of the advantages and the disadvantages of having no types in a language? You can't get this from the textbook. In fact, this question comes out of, it's a variation of a question that comes out of the end of the chapter 5 of one of the editions of the book. And so the way that you want to approach this is answering your own words. There's really no right or wrong answer. So, there are some right categories of answers and there's some wrong categories of answers. So some obvious advantages and disadvantages. Well, you could talk about, one of the obvious disadvantages might be a lack of type checking. You can't do any static type checking. And you know that from before the midterm when we talked about static and dynamic type assignments. And if we have no types at all, then how are we going to tell whether or not the operation is safe? So we just went over the mixed mode operations, and we just went over the kind of the variables and using things together. And so that's why, this is on chapter 5, but it really does cover some of the chapter 6 and chapter 7 material. You can use anything you want to actually answer these questions, but you can answer it just from chapter 5. And the stuff is in chapter 5, but you can elaborate in any direction you want, is what I'm saying. But you want to discuss this in a paragraph. A paragraph is 3 or more sentences. Okay, one sentence, one word or two, not enough. You want to use a whole paragraph, 3 sentences, 3 to 5 sentences. I don't want 3 to 5 pages. I want 3 to 5 sentences. And answer in enough detail so that I understand what you're meaning. For example, let me give you a model answer to this one. What are some advantages and disadvantages of having no types in a language? Okay, I would start out by writing one of the advantages of having no types is that it's easier for the programmer to actually create variables because they don't have to know anything about data types. They don't have to know what data types are supported and what predefined types are in existence, and they can actually use the data into its real, true, raw form. And so they don't have to predetermine what it is. Well, that's a good, obvious advantage. What's a disadvantage of having no type? I mentioned it already. I could say a disadvantage to having no types in a language is you can't really test it before the program runs. How are you going to do static type checking if there's no predefined types? And then also another disadvantage of having no types in language is that the user can do some nonsense, some stuff that doesn't make any sense. For example, they could take a float and add it to a character. That might be problematic in terms of the calculation. So they can do some stuff that doesn't make any sense at all. So you can write it like that. If you cut and paste it from the internet, you're going to get 0 points. If you cut and paste it from the book, you're going to get 0 points. If you just write that, or put it in your own words, you're going to get 100 points. You're going to get 5 points for the entire assignment. There's 5 questions. Each question is only worth 1 point each. And in some cases, it says, what is the general problem with static scoping? Is there a general problem with static scoping? Well, I don't want you to look into a crystal ball with all of the problems of static scoping, which aren't really that many, and come up with a general. And if you come up with the wrong general one, that's fine as well. Just come up with a problem. What is a general problem? Not the general problem, but what is a general? If you wanted to change it to a general problem, that would be okay too. So go ahead and give this assignment a stab. I want you to actually try the assignment. I want you to see if you can answer these questions. And because the next video I'm going to do is going to address the answers to these questions. I'm going to take and dedicate an entire video. Not happening this week, it's going to happen next week. This week is all about chapter 7. Next week is going to be about assignment number 6 and addressing these questions and kind of reiterating these points. But give this a stab first. And you don't necessarily need to turn it in yet. It's not going to be due for a couple weeks here. Let's go take a look at the syllabus while I've got a few moments here. The assignment number 6 is due on 4/29. And we are in the, let's see, today's Friday, so this is, I'm working on Monday's lecture, Monday and Wednesday of next week. So this, the week that you're watching this video in is going to be the 13th, 15th week, and you have program number 5 due that week, which is the object-oriented design program. And I highly recommend you watch the video I did on this one, because it'll make your life easier. Nothing's due next week. This week here, I'm going to go over the answers to number 6. But if you want to do number 6 first, I highly recommend it. Spend some time, if you've got the time. Everyone's got time right now, right? We all got time. Tons of time. Too much time, actually. Because of the stay-at-home stuff. But give it a shot. See if you can answer these questions. Just take a notepad out or something, or just write them in this document and write down some answers. And then I want you to check the answers when you watch the video I'm going to do on this. And I'll label the video that this is assignment number 6 review. I'll label that video so that you know what's up for that video. But give them a shot first and see how close you come up with what I say, because it's a better learning experience for you. So do that in preparation for the following week. I will clearly label the video so it says review of assignment number 6. So this video is technically the conclusion of chapter 7. Now chapter 7 did not have very much content in it. It was a very lightweight content. We still have another chapter left. We have chapter 8, but I don't want to go too fast through the material. Chapter 7 is pretty good reading, and probably next week I'm also going to crack open the book and show you a PDF of it and go through to tell you which sections out of chapters 5, 6, and 7 you want to be looking at. But for the most part, most of, if not 99.9% of chapter 5, 99.9% of chapter 6 and 7 it's all testable material. Actually 8 as well, by the way. There's not too many, maybe one section out of 8 that's going to be removed, but from your reading requirement. But for the most part, it's all very good material that you should focus on. So go ahead and give assignment number 6 a shot in preparation for the next week, and finish up any outstanding assignments that you might have so far. Finish up assignment number 5, if you haven't done that one, on the object orientation. That's a good one to finish because it's pretty easy. And maybe use this time to catch up if you can. And I will see you for another video. The next video will be on assignment number 6. Talk to you soon.